to this exercise. So in this exercise, in this short video, we will do an exercise about mean variance analysis. Here, this is the exercise. Here is the solution to this exercise. And after that, there is a question. So this is the solution. And here is another task for you to repeat after, once you watch this video and do this exercise yourself. You will have to repeat this in this question and answer this. You will upload this to our website where it will be provided to you. The link will be provided to you where you will be uploading this. So let's have a look at this question. The question is that the expected return and standard deviation in portfolio of two assets below or given below, stocks and bonds. Find the mix of two assets with minimum risk, right, with efficient frontier. So this is the two assets. Here it's stocks and bonds. The expected return here are given. So the expected return on stock is 10%, while the expected return on bonds is 3%. The variance of stocks is 215%, while the variance on return of bonds is 80%. Standard deviation for stocks is 147%, while standard deviation for bonds is 89%. The correlation between stocks and bonds is 0.25%. Now let's have a look what the task is. So we have got, for example, this is the stock share and this is the bond share. So initially we can see that it's 100% of our portfolio is stocks, and obviously the remaining 0% is bond portfolio. So we can see that over time we decide that we will decrease our share of stocks, while the share of bonds is increasing over time. So we reach by the end 100% of bond portfolio, and where we have a 0% of stocks portfolio. So let's look how we calculate the expected return on both these stocks and bonds. So the expected return formula is given here. We have a expected return is equal to W1 ER1. That W1 is one of our assets, so which is the shares, for example, and expected return 1 would be the return on stocks. So this is the W1 is the share of stock, and ER1 is the expected return on stock, plus W2 would be the share of bonds. Multiplying this by ER2 would be the return on bonds. So let's just calculate this here. Now be equal to W1 is this one, multiply this by expected return on stocks. Now we have to be careful a little bit here. This when we will be dragging this by the end, we'll be able to drag this down here, and the formula will be applying here as well. However, if we'll apply this here, these numbers are down here as well. However, we don't want the 10 to be changing in this formula. So that's why for the 10 not to change in this formula, what we do here is that put a dollar sign here and put a dollar sign here. So we have W times expected return of stocks, which is 10%. Now plus W2, which is this bond share, multiply this by stocks share, bonds expected return, which is 3%. Again, we have to put a dollar sign here and a dollar sign here. So we have a expected return of 10% for the whole portfolio. Now this is obvious because the whole portfolio contains only stocks. So that's why the return would be what the return for stocks would be, which is 10%. So we can see that because our portfolio is only stocks, so the return for the whole portfolio would be what the return for stocks would be, right? So we can now we can just come to this bottom and right bottom, and you will see the plus sign. This simply normally is like this, and then it becomes a black plus sign. So simply select this and drag it down, and it will apply this to the whole column. And we can see here that the expected return here for the portfolio of 0 and 100% is 3%. Now that is obvious because this return is 3% because the whole portfolio contains only only bonds, and there is 0% of our portfolio contains stocks. So we can be sure that the return on the whole portfolio would be what the return on bonds would be, which is 3%, which is 3% here as well. Now again, if we calculate the portfolio variance formula is like this. So this simply is like the formula for variance of I'll write this here, formula for you here. Variance have some properties. So when we apply variance, now because our portfolio here is now W1 ER1, it's W1 ER1 plus W2 ER2. So this is our portfolio now. We have a this is what we calculated the portfolio. So when we apply variance to this, variance of AX, this is a general formula, plus BY is, if this takes the form of like this, then the variance of something like AX plus BY, which this takes the form of AX plus BY, so A would be W1, X would be ER1, and B would be W2, and ER2 would be Y. So the formula for this is, for the variance of this is equal to, right here, equal to, so this is equal to A square variance of ER1 plus B square variance of ER2 plus 2 covariance of X and Y. So this is the formula. When we apply this formula to our situation, then we get this here. So we have A square here would be W square. So let's just do this here. What is W1 square? W1 is this one, the share of stocks. So put a square here, so power 2, multiply this by variance of stocks, where sigma square 1, so that's the variance of stocks, like here. So the variance of stocks, so just put a bracket here because there is a power, we don't want to get confused here. So variance is this one. Again, we have to put a dollar sign because we don't want this number to be changing, coming down here when we apply the formula to all of it. So put a dollar sign here. So this is W1 square sigma 1 square, now plus W2 square. Now W2 square is this one, which is the share of bonds. Multiply this by W1 square, so we have to apply power, and now start a bracket. Now we want sigma square 2, that is the variance of stocks, of bonds. Again, we have to apply a dollar sign here. Now the formula says that we have to, so plus 2W1 W2, so 2, multiply this by W1, which is the share of stocks, multiply this by W2, which is the share of bonds, and then we have rho is for correlation coefficient. Now this covariance of xy is equal to standard deviation of x1 multiplied by standard deviation of x2, and then multiply by correlation coefficient. So that's why we have replaced this by this. So let's now this is multiply this by correlation coefficient. Now again, we don't want this to be changing, so our dollar sign here, our dollar sign here, and then this should be multiplied by standard deviation of stocks multiplied by the standard deviation of bonds. And click enter. Did we make a mistake? So this is a 215%. Let's just bring this down here, and we can see that we have a so when our total portfolio contains 100% stocks, our portfolio variance is 215%. Now that's exactly the same as the stocks variance. And when our total portfolio is contains bonds only, which means 0% stock share, then our total portfolio variance is 80%, which is exactly the same as the variance of bonds. So that obviously makes sense. Now after this, we want to calculate a standard deviation for the portfolio. Now we know that standard deviation simply is the square root of variance, so this should be equal to this power 1 by 2 or 0.5. For power we use this sign. We use this sign for power. So if this is equal to this, or we can simply write also, we can write equal to square root, which is SQRT, and then this, and bracket close, and then we get this number. So we can see that the standard, we'll simply drag this down here, and the same applies to all of this. So we have the standard deviation of our portfolio is like this. So I'll simply now clear this because we don't need this. Now let's just draw a graph of our expected returns against the standard deviation of our portfolio. So we click insert, and let's just take scatter diagram, and let's select this one. So we selected a diagram, but of course it's still empty. So what we do here is that we click on this, select data. So what we want is our y, we start a series, and in that series our x variable is portfolio standard deviation. So select this whole data and then click this. Again, our y variable, just click on this so that we can select data, is expected return. Now click this again, and we can click OK, and this is our data. We can see that it is starting from 0%, so we want this to be starting from somewhere around here so that we can see the graph more properly. So let's just click this. Let's look at these numbers and click on this, and let's just start this from 0.8. So that's is that from 0.6? Yeah, that's better. So we can then give this a title. Expected return. So we can see that our expected return initially decreases with increasing. Our expected return increases initially with lower standard deviation, and then it increases further with the after some time it increases with the greater standard deviation. So the more there is deviation, the more return we get from our portfolio. You can also apply some excess here, so we can write that this is our portfolio standard deviation. And we can write here that this is our expected return. So this is the exercise. Go to the question. You will find the file on the website. Go to the question and solve the question and upload your answers. Thank you very much.